Good morning. Today we'll discuss about mesh analysis. In the last lecture, we have discussed about source transformation. We have seen that there are two types of sources which are available. One is voltage source and current source. Ideally, they won't be having any resistance, but when we use them in circuits, we need to represent them with their equivalent circuits. So practically, any voltage source or a current source will be having some resistance which is associated with it. And a voltage source will be having a resistance which will be in series with it. This is a practical voltage source. Whereas a current source will be associated with a parallel resistance of a large value associated with it. So this is a practical voltage source and this is a practical current source. And how to interchange between these two, that we have discussed in our last lecture. In today's lecture, we will discuss about mesh analysis. I hope that by the end of this lecture, you will be able to describe the steps involved in mesh analysis. So this is not nodal, this is mesh analysis today. Mesh analysis of the given network. So I'll start with the basic introduction to mesh analysis, and then we will move on to describe the steps involved in mesh analysis, and then we will try to solve a simple problem on mesh analysis. Coming to the introduction, mesh analysis is one of the circuit analysis techniques which is used to determine the current flowing through each branch of a circuit. Let us suppose I do have a very big circuit. There are so many elements which are present in this one. Some current sources, some voltage sources are there, too many elements are there. So if I want to determine current through any of these branches, then mesh analysis is the best method to determine it. It is based upon your KVL, which we have discussed in our week number 1, Kirchhoff's voltage law, which states that algebraic sum of voltage drops across all elements is equal to 0 in a loop. Let us suppose this is a loop, 3 elements are there. This is V1, this is V2 and this is V3. V1 plus V2 plus V3 is equal to 0. This is what your KVL says. And mesh analysis is considered as one of the powerful tools for solving complex circuits, particularly in communication and electronics engineering. So, how to perform this mesh analysis? To perform the mesh analysis, the first step is to divide the circuit into meshes. You know, mesh is nothing but a closed loop. We have seen in week number 1. Mesh is the tiniest loop in your electrical circuits. It must be a closed loop and the tiniest one. It cannot be broken into some other loops. Say, I will say. Okay. Now this is one loop. This is also a loop. And this is also a loop. Loops can be many. Loop is nothing but a closed thing. But whereas coming to a mesh is a loop, but it cannot be divided furthermore. Which means that, see, this is one mesh. And this is another mesh. Even though if I take the biggest one, it can be considered as a loop, but it shouldn't be treated as a mesh. Why? Because a mesh is a one which does not contain any other closed loops. See, this loop is containing 2 loops again. So that's why it cannot be treated as a mesh. So that's why mesh is the tiniest loop which cannot be further divided. Okay, so try to remember that one, mesh. And your first step is divide your network into meshes, and then number of meshes must be equal to number of essential branches. This you will see in your next semester. And for each mesh, you write KVL. This is the third step. And once you write the KVL, you will get the mesh equation, or we call it as a loop equation. and those are to be solved to determine the responses in all the elements. So simply this is the mesh analysis. Identify the loops, write KVL for each one, and then solve these equations. So I have put them in a serial order for you. See, 6 steps I have made for you. The first one is identify the number of meshes, and then for each of the meshes you assign a current. Assume that the mesh current which is assigned, it starts from the top left of the mesh. And identify the currents. Once these mesh currents are identified, you identify the current flowing through each of these elements present in the mesh along with its direction. Okay, and then you apply KVL to each of these meshes. You know the KVL, right? Algebraic sum of the voltage drops across all elements in a mesh is equal to 0. So you start with the top left and return to the same point in clockwise direction. And then you determine the mesh currents by solving these equations. How many equations, how many meshes are there, that many number of equations you will get. Solve them to determine the mesh currents. And finally, once you have the mesh currents, you determine the branch currents. These are the 6 steps. So the first one is number of meshes, assign each one a current, and identify the current flow. Up to here, there is no problem for you. Next comes writing KVL equations for each mesh, solving them, and then determining the final. There are some limitations for this mesh analysis because it is employable only for planar circuits, and if the number of meshes increases, then the number of equations also will increase, which will be a little bit complex for solving the problem. So let's start with a simple problem on mesh analysis for today. So this is your network. So you are supposed to find the voltage across this 30 ohms resistor using mesh analysis. So how to determine the voltage across this one? So first of all, let me explain, then I'll give the steps for you. See, let me draw the circuit again. This is your circuit, right? Now the first step is identify the meshes. Identify the number of meshes. How many meshes are there in this one? This is one mesh. This is second mesh, right? So identify the number of meshes. How many meshes are there? 2 meshes are present. And given circuit. Number 2, second step. What is the second step? Second step is assign current to each mesh. So what I will do, I'll take from the top left, it is I1, and here it is I2. 2 meshes are there, I1 and I2. Right. Step number 3, identify current flowing in each element. So if you find it difficult, then see, here I1 is starting, here I2 is starting, right? So this I1 up to here it is I1, again it is moving to I2, so automatically what will be the current which is flowing in this one? It is I1 minus I2, right? And here also in this one I2 will be flowing again here. This is a voltage source, right? So what is the current which is coming out of this one? I1. See how many, let us make a table of this one. It will be easier for us. What is the element and what is the current flowing and what is the direction of current? How many elements are there? There are 3 resistors. 5 ohms resistor is there, 10 ohms resistor is there, 30 ohms resistor is there. In 5 ohms resistor, what is the current flowing? I1 is the current flowing. And from which direction? It is going from left to right. And coming to 10 ohms resistor, the current is flowing is I1 minus I2. And see what is the direction of current from top to bottom. And for third resistor, it is 30 ohms resistor, the current is I2, right? So it is also going from left to right. This will help you a lot in your initial stages, okay? So the next thing, what I will do is nothing but I'll write apply KVL for each of the loops. How many loops are there? 2 loops are there. For each of the loops, I'll apply KVL. This is we have done this one in our class, right? So I'll start with loop number 1. So let me draw the figure again. This is I1, this is I2, and this is I1 minus I2, right? Now, for mesh 1, I am writing the equation. How many elements are there in the mesh 1? See, this is mesh 1. 1, 2, and 3. So, 3 voltage drops will be available. Right, sum of voltage drops across 3 elements. So, I'll start with top left. So, if there is any voltage drop not available, directly you take I into R. If it is available, directly you take V. Either of these two options. I'll start from here. This is a resistor. So what I'll take 5 into I1. It is in the same direction of the current, right? 5 into I1. From here, see, is the direction of the current same? Yes. So what is the current? I1 minus I2 into resistance is 10. For this one, here, this is the direction, but I am moving from minus to plus. So what I'll take it as minus 20. So if you solve this one, you will get 15 I1 minus 10 I2 is equal to 20. This is your equation number 1. Right. So coming to mesh 2 now. How many elements are there in mesh 2? 1, 2, and 3. So here also I'll start from top left. Right. 3 elements are there. From here I'll start. What is the voltage drop here? 30 into I2. See, I'm moving from minus to plus. So I'll get minus 80. Again here I'm moving from, see the current is in this fashion, but my loop direction is in this fashion. So what I'll get minus I1 minus I2 into 10. So here minus 10 into I1 minus I2. So instead of plus I should write here minus 10. Right. So if you solve this one, what you will be getting, see this is 30 I2, this is minus 80, this is minus 10 I1, this is plus 10 I2. So if I write it, I'll get 10 I1 minus 40 I2 is equal to minus 8. These two are the equations. So let us solve them. So what are the two equations? What is step number 5? Solving equations, which we have obtained in step number 4. In step number 4, what are the equations? The first equation is 15 I1 minus 10 I2 is equal to 20. What is the second equation? 10 I minus 40. So you should solve these equations. What I will do, I will multiply it with 4 and I will multiply with 1. So this will become 60 I1 minus 40 I2 is equal to 80. This is 10 I1 minus 40 I2 is equal to minus 80. So if I subtract them, this will go off. This is 70 I1. Sorry, 50 I1 is equal to 160. So what is I1? 160 by 50. What is it? 3.2 amperes. So if I substitute it in any of these equations, I'll get I2, isn't it? So what is I2? If I substitute it here, 10 I1 minus 40 I2 is equal to minus 80, right? So I1 is 3.2, so 10 into it is 32. So I2 is equal to minus 112 by minus 40. 4 3 is a, so 4 2 is a 8, so it is 2.8 amperes. Right. So once you have done it, then what we will do, we will determine the branch currents. We have seen in step number 3 how to write these things. See, this will be helpful for us. Right. So I'll draw it here again for you. This is 5 ohms, 10 ohms and 30 ohms. This is I1, this is I2 and this is I1 minus I2. So what was the element and what was the current? Direction. This we have written already, right? I1. So this is 5 ohms resistor, 10 ohms resistor and 30 ohms resistor. What was the current in this one? It is I1. It was I1 minus I2. It was I2. The direction was from left to right. It was from top to bottom. It was from left to right. Now we will calculate now what is the current magnitudes. We have already obtained, right? What is I1? I1 is 3.2 and I2 is 2.8. So if I substitute this one, what I will get? I1 is equal to 3.2 amperes. Here it is 3.2 minus 2.8, it is 0.4 amperes. And here it is 2.8 amperes. If I want voltage drop across this one. So how to determine the voltage drop? This into this. This is resistance, right? Resistance into current, right? V is equal to I into R. So 3.2 into 5. It is 16 volts. This is 0.4 into 10. It is 4 volts. It is 2.8 into 30. It's 56. $84 volts. This is the simple thing, how you can solve this problem. Understand? So what you wanted? You wanted voltage across any of these elements. 30 ohms, though it will be voltage across 30 ohms. It is 84 volts. In which direction? From left to right. So this is plus, this is minus. It is 84 volts. Understood? This is the way how we solve the problems using mesh analysis. Okay, I hope you have understood, and I have mentioned it in stepwise for you. So you follow this one and try to solve the problems in the class and also practice them at home. Okay. So I hope that now you are able to describe the steps and determine the response in any element using mesh analysis. Okay. Thank you. This is your practice problem. See, I have given you 3 ohms resistor. There are so many resistors. You need to determine the current in this resistor using mesh analysis. Remember the 6 steps, follow your 6 steps and try to determine the current in 3 ohms resistor. Okay, so that's it from my side.